Good morning, my dear students. I am your ma'am, Archana Garpelli, Assistant Professor of Chemistry, Government Degree College, Bainsa and Nirmal, District Nirmal and Telangana State. Today we will discuss Inorganic Chemistry P block elements 2. In this lesson, we discuss about oxides. So, in our PPT, today we will discuss about types of oxides. According to CC guidelines, we are preparing video lessons for you students. So, in this situation, don't go outside and stay home, stay safe and follow SMS. Are you following SMS method? SMS means not a message. SMS is social distance, mask and sanitizer. So follow SMS method, stay home and stay safe. These YouTube video lessons are very useful for you, my dear children. So follow every video. So if you follow every video, you can understand very well. So subscribe the channel and follow my videos and learn chemistry. Be happy, be practical. Before going to the class, I will tell you some introductory notes. That is, do you know how many blocks are there in the periodic table? Yes, there are 4 blocks in the periodic table. They are S block elements, P block elements, D block elements and F block elements. Do you know what is S block elements? Yes, S block elements means the penetrating electron enters into the s orbital known as S block elements. So these are at left side of the periodic table. These are 2 groups. They are first A group elements and second A group elements. And second one is P block elements. The penetrating electron enters into the p orbital known as P block elements. These are 3rd A, 4th A, 5th A, 6th A, 7th A and 8th group, like the 0 group elements. So these all 6 groups are known as P block elements. And D block elements. D block elements means the penetrating electron enters into the d orbital known as D block elements. These are between the S block elements and P block elements. They are 4 groups, that is 3rd B, 4th B, 5th B, 6th B, 7th B, 8th group, 1st B and 2nd B. So these are total having 10 groups, right? And F block elements. So F block elements means the penetrating electron enters into the F orbital known as F block elements. So these elements are 2 series. They are 4F series and 5F series, or lanthanides and actinides. These are at bottom of the periodic table. Right, understand? So coming to the topic. Today's topic is oxides. So what is oxide? Oxide is nothing but elements that reacts with oxygen or burn with oxygen to form oxides. Example, in Diwali, we crack the magnesium ribbon Yes, are you remember the magnesium ribbon? Yes. So magnesium ribbon reacts with or burn with the oxygen and forms some type of ash. So that ash is nothing but magnesium oxide. Another example is we keep the iron utensils outside, then some type reddish brown color uh, powder will be get on the surface of the iron utensils. So why it happened? Once you think, what is the reason? Yes, the reason is iron reacts with the atmosphere oxygen and forms iron oxide. So this iron oxide is nothing but rust. Okay. So this is one type of oxide. These are the examples of oxides, right? Another definition is an oxide is a chemical compound that contains at least one oxygen atom and one another atom or another element, right, in its chemical formula. Oxide itself is the dianion of oxygen and O minus 2 atom. So metal oxides thus typically contain an anion of oxygen in the oxidation state of minus 2. Right. Next is types of oxides. So there are 5 types of oxides. Number 1 is normal oxides or simple oxides. Number 2 is mixed oxides. Number 3 is suboxides. Number 4 is peroxide and number 5 is superoxides. In normal oxides, the oxidation state of oxygen is minus 2, whereas in peroxide is O2 minus 2. Most of the earth crust consists of solid oxides. The results of elements being oxidized by the oxygen in air or in water. Even materials considered pure elements often develop an oxide coating. For example, aluminium foil develops a thin skin of Al2O3 called a passivation layer that protects the foil from further corrosion. Certain elements can form multiple oxides. The increase in oxidation state of atom through a chemical reaction is known as an oxidation. A decrease in oxidation state is known as a reduction. Such reactions involve the formula transfer of electrons, a net gain in electrons being a reduction and a net loss of electrons being an oxidation. For pure elements, the oxidation state is 0. The oxidation state of an atom does not represent the real charge on the atom or any other actual atomic property. This is particularly true of high oxidation state, whereas oxidation energy required to produce a multiply positive on greater than the energies available in chemical reaction. Additionally, oxidation states of atoms in a given compound may vary depending on the choice of electronegativity scale used in their calculation. Thus, the oxidation or state of an atom in a compound is purely formalism. It is a so my dear students, please listen. That is, how many types of oxides are there? Yes, there are 5 types of oxides. Number 1 is normal oxides or simple oxides. Number 2 is mixed oxides. Number 3 is suboxides. Number 4 is peroxide. And number 5 is superoxides. Right? The first one is normal oxides. So in this normal oxides or simple oxides is one carrying a number of oxygen atoms that the normal valency of its metal allows. For example, H2O, MgO and Al2O3 etc. Right. We have 4 types are there. They are, number 1 is acidic oxides. Number 2 is basic oxides. Number 3 is amphoteric oxides. Number 4 is neutral oxides. So acidic oxides are nothing but it is an oxide of a non-metal. It dissolves in water to form an acid. Acidic oxides reacts with alkalis to form a salts. Then basic oxides. A basic oxide is an oxide of a metal. It's soluble. It will dissolve in water to form an alkali. So basic oxides are react with acids to form salts. The next one is amphoteric oxides. So amphoteric oxide is an oxide which can react with both acids and alkalis to form salts. And a neutral oxide does not react with either acids or alkalis. Yes, understood? So we have 4 types of oxides: acidic oxide, basic oxides, amphoteric oxide and a neutral oxide. Right. So the first one is acidic oxides. So what are acidic oxide? Acidic oxide is nothing but oxides of non-metals. So non-metals, for example, sulfur, nitrogen, chlorine. So these are the non-metals. This can form oxides with oxygen in acidic nature. Yes. In acidic oxides, the examples are SO3, NO2, etc. Oxide reacts with water and produces acids. Usually it is the oxide of non-metals. Examples include SO2, CO2, SO3, Cl2O7, P2O5 and N2O5. It could also be the oxide of metals with high oxidation states such as CrO3, Mn2O7 and V2O5. Sulfur dioxide reacts with water and gives sulfuric acid. So in acidic oxides, another example is N2O5. So N2O5 dissolves in water and forms HNO3 nitric acid. So this is also one of the examples for acetic oxide, right? So SO2 plus H2O gives rise to H2SO3. H2O is water and SO2 is sulfur dioxide and the oxide is H2SO3 sulfurous acid. Chromic anhydride reacts with water and results in chromic acid. Cr2O3 plus H2O gives rise to H2Cr2O4. So Cr2O7 is chromium oxide and H2O is water and H2Cr2O4 is chromic acid, right? When oxidation state of element increases, then the strength of acid increases. And another examples are sulfur trioxide, that is SO3, and sulfur dioxide SO2, carbon dioxide CO2, phosphorus oxide is P4O10. So a first one, sulfur trioxide is a acidic oxide. Why sulfur trioxide is a acidic oxide? Yes, sulfur trioxide dissolves in water and forms sulfuric acid. Yes, so sulfur trioxide reacts with water and forms sulfuric acid, that is H2SO4, and sulfur dioxide also reacts with water and forms sulfurous acid. Just now we have seen the reaction in the last slide, right? Then carbon dioxide. So carbon dioxide also dissolves in water and forms carbonic acid, that is H2CO3. And so next one is phosphorus oxide. So the formula is P4O10 and the acid is phosphoric acid. The formula is H3PO4. When the group number increases, the strength of the acid increases, right? For example, fourth group, that is carbon oxide, is carbon dioxide. The acid is carbonic acid. And sixth group element is sulfur. The sulfur oxide is sulfur trioxide, right? So the sulfur trioxide or acid is sulfuric acid. So carbonic acid is less acidic than the sulfuric acid, or sulfuric acid is more acidic than the carbonic acid, right? And the next oxide is basic oxide, so which is a simple oxide. So basic oxides are nothing but oxides of S block and D block elements or metals are known as basic oxides. So what are the S block elements? S block elements are first A and second A group elements. These elements also known as alkali metals and alkaline earth metals. So what are the alkali metals or first A group metals? They are lithium, sodium, potassium, rubidium, cesium and francium. And second A group elements are beryllium, magnesium, calcium, strontium, barium and radium. So these elements are forms oxides, and these oxides dissolves in water and it forms basic nature or bases. So that's why these oxides are known as basic oxides, right? For example, D block elements also. D block elements, metal oxides, also known as basic oxides. You know very well the D block elements are in between the S block and P block elements in the periodic table, right? So these D block elements, oxides, also known as basic oxides. Example, S block elements, oxides. So lithium oxide, sodium oxide, potassium oxide, and cesium oxide, magnesium oxide, calcium oxide. So these oxides dissolves in water, they form alkalines or bases. So that's why these oxides are known as basic oxides. So you see in this slide, magnesium oxide, the formula of magnesium oxide is MgO, and the formula of sodium oxide is Na2O, and the formula of calcium oxide is CaO, and the formula of copper oxide is CuO. So these oxides are dissolved in water and they form bases. So for example, magnesium oxide dissolves in water and form magnesium hydroxide, and sodium oxide dissolves in water and forms sodium hydroxide. Calcium oxide dissolves in water and forms calcium hydroxide. So when copper oxide also dissolves in water, it forms copper hydroxide, right? So these all oxides dissolves in water, they form hydroxides. So that's or these are basic in nature. So that's why these oxides are known as basic oxides, right? So the reactions are MgO, magnesium oxide, plus H2O, that is water, gives rise to MgOH taken twice, right? Then CaO plus H2O gives rise to CaOH taken twice. CaO is nothing but calcium oxide and H2O is water. It gives calcium hydroxide, right? The next one is BaO plus H2O gives rise to BaOH taken twice, that is barium oxide plus water gives rise to barium hydroxide. So these hydroxides, all these hydroxides are in basic nature, right? The basicity of oxides when increases from top to bottom, that is in first A group elements lithium oxide and in the last one is cesium oxide. So lithium hydroxide is less basic than the cesium hydroxide. So cesium hydroxide is highly basic in nature or strong base, and lithium hydroxide is weak base. Next, oxides or amphoteric oxides. So these oxides which can react with acids and bases known as amphoteric oxides. So the examples of these acids are zinc oxide and aluminium trioxide. So these oxides, that is zinc oxide and aluminium trioxides, they react with acids as well as bases. So that's why these oxides are known as amphoteric oxides, right? An amphoteric oxide is that metallic oxide displaying a dual behavior. It shows the characteristic of both an acid as well as base. So it reacts with both acids and alkalis. Just now we have seen zinc oxides and aluminum trioxide are the examples. Yes. So this zinc oxide acts as an acidic oxide when it reacts with concentrated sodium hydroxide. However, it acts as a basic oxide while reacting with hydrochloric acid. Aluminum trioxide also same. So these aluminum trioxide acts as an acidic oxide when it reacts with the concentrated sodium hydroxide. However, that is base, and however it acts as a basic oxide while reacting with hydrochloric acid, which is a acid, right? So these are the two examples. So you see the reactions when zinc oxide dissolves in water and reacts with sodium hydroxide and forms Na3ZnOH taken 4 times plus H2 or hydrogen gas. It releases hydrogen gas. And when zinc oxide reacts with 2HCl, gives rise to zinc chloride plus water. So here ZnO plus 2HCl gives rise to ZnCl2 and H2O. So here zinc oxide, which is a base, and 2HCl, that is acid, it forms zinc chloride, which is a salt one, plus water. This one is one of the neutralization reaction, and in the first reaction zinc oxide plus 2NaOH gives rise to Na3ZnOH taken 4 times plus H2. So here also zinc oxide acts as acid and sodium hydroxide, which is a base. So in these reactions, in first reaction zinc oxide acts as acidic nature or acid, and in the second reaction zinc oxide acts as a base. So that's why these zinc oxide are having dual character or dual nature. So that's why these oxides are known as amphoteric oxides, right? The oxide is neutral oxides. So when oxides which does not react with acids or bases, known as neutral oxides. So these oxides does not react with the acids and also bases. So these reactions are known as neutral oxides. So what are the examples of neutral oxides? And another definition is a neutral oxide is one that does not exhibit any tendency to form salts either with acids or bases, right? A neutral oxide is one that does not exhibit any tendency to form salts either with acids or bases. The examples of neutral oxides include nitrous oxide and carbon monoxide. Yeah. So what is the formula of nitrous oxide? What is the formula of carbon monoxide? Yes, you are right. The formula of nitrous oxide is N2O and the carbon monoxide is CO. Right. So carbon monoxide is CO and nitrous oxide is N2O. This is also known as laughing gas. And water also one of the example for neutral oxides, right? So what is the formula of water? You are right, H2O. Here in this slide, names and formulas are there. So neutral oxide and the formula. So first one is water, that is H2O, and second one is carbon monoxide, that is CO, and nitric oxide, also one of the neutral oxide. So nitric oxide formula is NO. These oxides, that is water, CO and NO, does not react with acids or bases to form salts. So that's why these oxides are known as neutral oxides. There is no reaction with the acids and also as well as bases. So these are the normal or simple oxides. So what are the normal and simple oxides? Yes, first one is acidic oxide, second one is basic oxides, third one is amphoteric oxides, and fourth one is neutral oxides, right? Examples of acidic oxide is sulfur trioxide and sulfur dioxide, carbon dioxide. Examples of basic oxides are lithium oxide, potassium oxide, calcium oxide, and neutral oxides are water, CO and nitrous oxide. And the examples of amphoteric oxides are that is aluminum trioxide and zinc oxide. And next one is the mixed oxides. So we get a mixed oxide upon the combination of two simple oxides. So for example, lead monoxide and lead dioxide, when combined with each other to give a red color oxide. So this oxide is known as mixed oxide. And example number 2. So that is ferric oxide. When ferric oxide and ferrous oxide combine together and forms the mixed oxide, that is ferroferric oxide. So the formula of lead monoxide is PbO and lead dioxide is PbO2. So these PbO and PbO2 when combined together to give a red lead, that is Pb2O3. So this Pb2O3 is a mixed one. So Pb2O3 is known as mixed oxide, right? The next one is ferroferric oxide is the example. The formula ferroferric oxide is Fe3O4. So this Fe3O4 is formed the combination of two simple oxides. They are ferric oxide, that is the formula ferric oxide is Fe2O3, and ferrous oxide, that is the formula ferrous oxide is FeO. So these Fe2O3 and FeO combined together forms Fe3O4. So the reaction of this one is Fe2O3 plus FeO gives rise to Fe3O4. Mixed oxides are formed by the combination of pure oxides or the combination of two pure hydroxides. So we have seen the oxides, that is Fe3O4 and Pb2O3. So these oxides are pure mixed oxides. So what is the definition of pure mixed oxide? So pure mixed oxides are formed by dehydration of only one type of oxides, hydroxides, or the combination of only one type of oxides are known as pure mixed oxides. So next oxide is peroxides, a group of compounds with the structure R bond O bond O bond R. The oxygen-oxygen single bond group in a peroxide is called the peroxide group or peroxide bond, right? So in common oxides, oxygen forms double bond, but in peroxides, the bond between two oxides is a single bond. So we can identify the peroxide by a single bond, right? In peroxides, the oxidation state is -1, that is O2 -2. So each oxygen carries -1. So O2 -2 ion is known as peroxide ion. It may be regarded as salts of the every weak acid. For example, hydrogen peroxide. The examples are sodium peroxide, that is Na2O2. It is a bleaching agent. And barium peroxide. The formula of barium peroxide is BaO2, formerly used as a source of hydrogen peroxide. So the examples of peroxides are Na2O2 and BaO2. The common peroxide is hydrogen peroxide, that is H2O2. So we can prepare various oxides from H2O2 with the other elements, right? So you see the formulas of peroxides, that is sodium peroxide, the formula is Na2O2, and barium peroxide, the formula is BaO2. So in these oxides or in these peroxides, the oxidation state of oxygen is -1, right? Oxidation state of sodium is +1 and barium is +2. So next oxide is superoxides. So superoxides are the compounds having O single bond O bond. Oxygen in the oxidation state is -1/2. In superoxides, the oxide ion is O2-. The systematic name of the anion is dioxide ion. So that is O2-. The reactive oxygen ion superoxide is particularly important as the product of the 1 electron reduction of dioxygen O2. So which occurs widely in nature. So molecular oxygen, that is dioxygen, is a diradical containing 2 unpaired electrons, and the superoxide results from the addition of an electron which fills one of the 2 degenerate molecular orbitals, so leaving a charged ionic species with a single unpaired electron and a net negative charge of -1. So both dioxygen and the superoxide anions are free radicals that exhibits paramagnetism. The examples of superoxides are KO2, RbO2 and CsO2. So commonly the first A group elements are alkali metals forms superoxides. So in this class we learn about definition of oxides and types of oxides. So we have different types of oxides. They are simple or normal oxides. Second one is the mixed oxides. Third one is suboxides, and fourth one is peroxides, and fifth one is superoxides. Right. So we learned examples of different types of oxides. Thank you one and all. If you have any doubt, please call me. So bye bye. Take care of yourself. Don't go outside unnecessarily. Stay home and stay safe. Take precautions. Thank you. Yours, Achana ma'am. So we will meet you tomorrow. Take care. Bye bye.